Okay, hi everybody. So we're gonna look at a map with this formula. Now this formula is in blue color, which means the actual formula might change. In particular, it might not be 2 dimensions to 3 dimensions, and the actual formulas will change, but you can answer the question in the same way. Okay, so explain how to convert this to y equals f of x notation and f colon Rn to Rm notation. Or I would read this like f maps from the inputs to the outputs. Okay, so first we see that there are 2 numbers here and 3 formulas here, 1, 2, 3, separated by commas. Okay, and so the parentheses here are just serving as containers, and the commas are dividers between the 3 different dimensions. Okay, and so what that means is that the input space is 2-dimensional space, and it's been labeled with x1 and x2. And the output space has 3 different components, so it's 3-dimensional. And it's tempting to label the dimensions like as x1 squared, but that actually doesn't make sense. And x1, x2, maybe the second. But that's not what we're doing here. We need to invent new names for these 3 output dimensions if we want to name them. So in this case, I will name them as y1, y2, y3, so we can use y equals f of x later. Okay, and then what happens here is this is the map. Let's call it f. So let's call this map f. And what it does is it would take some subset. So let's say I take a rectangle here. Let's call this rectangle A. It's a 2-dimensional rectangle in the input space. And then f maps it over in some way to, and I'm just making up what it looks like. I don't know how to, I usually draw the same thing every time because it helps me. And then this thing, this 2-dimensional surface here, is what we would call f of A, or f applied to A. So here the parentheses mean I'm applying the map f to the subset A, which is actually in the input space. So whatever's here is the inputs. The parentheses mean we're applying this map f. Okay, so we're gonna have to explain that in words later. Okay, so now this is my picture. Explain how to convert this map to y equals f of x notation. So over here, we see that, well here, let me write out in formulas. Let's just rewrite the map. x1, x2 gets mapped over to x1 squared, x1, x2, and x2. And you see, I gave more space here, so I can visually see. Now I'm going to invent new names, y1, y2, y3. And so what this means is that y1 is x1 squared. I just read that off, saying the first component is that. The second component, I read off y2 is x1, x2. And the third component, I read off y3 is x2. Okay, and if I wanted to, this is the map f, is doing this with these specific formulas. Instead of calling it y1, I could call this, f1 of x. Instead of calling it y2, I could call it f2 of x. And I could call it f3 of x. So it's important to see all these different notations because you'll see them in textbooks in physics and chemistry and math. And everybody uses a different one. And by the way, look at here, I've abbreviated. I've called this whole thing just x. And it's in R2, so it really has a first and second number called x1 and x2. So if I wanted, I could really be more specific and say f of x1, comma x2, f2 applied to x1, comma x2 is equal to x1, x2. f3 applied to x1, comma x2 is just x2. That's what this formula means. So these are just different names, but right here is the y equals f of x notation. Okay. Now we need also this notation, so let me give some more space. Right here, I usually write the input space and the output space, and then we name the map right here. This is just where we're naming the map. So maybe I put in words. Name the map. Sometimes people name the map right there. And then underneath we put the names of our inputs. So here are names of inputs. And then here we're seeing formulas and names of outputs. Okay. So then I think I'm done with this and this. And now I just need to explain the parentheses. So I'll say here the parentheses mean apply the map that we named f. We named it somewhere. And take that map f and apply the map f to the inputs. And I say inputs because actually we have a whole infinite set, this whole rectangle of inputs. The input's A. Okay? And then f applied to A is now a subset of three-dimensional space because f maps R2 to R3. All right. What else? Okay, here, the parentheses. That's also what the parentheses mean here, so I'll put this up here too. These parentheses mean apply the map f to the input x. Same with these, the inputs x1, x2, apply the map f1. Okay, and now, but what about here and here? So over here, let's grab this and say these parentheses are just containers for the three formulas or the three dimensions. In this case, these are the dimensions of R3. Whereas over here, these parentheses are the containers or formulas for the 2 dimensions of R2. And that's basically it. Okay, so part B was there and there. All right, you can pause and make sure you're okay with this answer. It has words, pictures, and formulas. And now I was quizzing myself, so I tried to just go through this answer a second time. Now here was my first answer. So now you can pause and try to look at a different way for me to answer this question with maybe more words and then similar pictures and formulas. I think this answer was a little bit more neat, and I liked this introductory words. But either works.